recording. Okay, so this is really the last topic in ER models that I'm going to cover. There's other things that ER models can show, but they're used so seldom that it's not really worth it. But what I'm talking about today is a relationship that happens all the time. Lots and lots of data has this kind of relationship. It's a relationship of inheritance, or where we can say something like entity 2 is an entity 1, or entity 2 is a type of entity 1. And that's something you're very familiar with. It's the kind of subclass, superclass relationship. And it can also be known as specialization and generalization, or one or the other. So those words actually mean the same thing. It just depends which direction you're going. So specialization is when you have an entity or a class, and you realize that it can be broken into subclasses. Generalization is the opposite. You've kind of done your design and you have many entities, and then you realize that they're all kind of related. They're all variations of one another. So that's called generalization. Basically, one is kind of going up from the little to the higher class, and specialization is going down from the superclass to the subclass. So in ER models, when you have a subclass relationship, that subclass inherits the attributes and the relationships of its superclass. So if you have that kind of relationship showing, it means that the subclass is like a duplicate of the superclass plus extra, just as in object-oriented programming. So in an inheritance relationship, the cardinality, as you expect, is 1-to-1, because you're saying that E2 is a type of E1, so they're somehow the same thing. So they're 1-to-1 relationship. Also, it's an identifying relationship because they're sharing the same unique identifier. Because one is just a subclass of the other, they have the same identifier. Also, because it's like an identifying relationship, then for the subclass, the participation in the relationship is mandatory. And for the superclass, it may be optional. For the subclass, it doesn't make sense that you have a subclass instance that isn't also the superclass instance, kind of obviously, because they're one and the same. They share the same identity. So there's different notations for this. So this first one here, it's called enhanced ER, and we find it presented in the book by El-Masri. I'm not so sure that it appears in any other texts, but they use this kind of upward facing U, where E2 is a subclass of E1. Another notation is the same notation that you use with class diagrams in UML. and the arrow always points from the subclass to the superclass. So in this case, E2 is a subclass of E1. In regular ER that we're used to, this is the equivalent notation that E2 is in an identifying one-to-one relationship with E1. In that case, it means that E2 shares the same identity as E1, and it must be in that relationship. So you can show it in regular ER without this special notation, but I think this second one, the UML class style, is the more recognizable one because everybody knows the class diagram style as well. Oops, sorry. So now there's an idea of inheritance and specialization, generalization, that there's no way to depict in regular ER. And that's these idea of specialization hierarchies. So if we imagine we have the employee entity, we can specialize it in multiple different ways. We can say that employees can be divided into specializations by the type of job they do. So for example, engineer and administrative person. So they're being divided by their type or specialized by type. Another way you might specialize employees is by how they get paid. So there's quite a bit of difference between the way a salaried person gets paid and an hourly person gets paid, and different way they get their benefits and different ways their contracts are written and different schedules that they get paid on. So it might be that you divide your employees into those subclasses. So that requires some new notations, which you see here, and I will explain, and then we'll look at them more in detail. So if you have a specialization hierarchy like that, where you say this superclass can divide into this set of subclasses, then there's two new constraints that you can show in the models. I think, do you see a screen with text on it? Okay, here it is. So the first constraint is called disjointness. And so the choices for that are either disjoint or overlapping. Disjoint means that every instance of the superclass belongs to only one of the subclasses in that hierarchy. Whereas overlapping means that the superclass instance may belong to one or more of the subclasses. And we'll see examples of those. And there's another constraint, and that's called the completeness constraint. So the completeness constraint describes whether or not every instance of the superclass plays a part in the subclass hierarchy. So is it possible to have something in the superclass, one instance in the superclass that doesn't belong to any of the subclasses? So total means that there's every instance of the superclass belongs to at least one of the subclasses, and then partial means that there can be some instances that don't fall into any of those subclasses. So now let's see how to indicate those two constraints on this same example hierarchy with the employees. So the employees, we broke them into two different hierarchies, and that's completely possible. There could be any number of hierarchies. There could also just be some one-to-one subclass, superclass relationships. But I think most often there are hierarchies. So this isn't showing. Okay. So these circles here, they talk about the disjointness constraint. And what you find inside the circle is either O or D. I put a capital D, but I guess a capital D looks too much like an O, and I should have used a small letter D. So in this case, both of these hierarchies are disjoint. So one employee cannot be salaried and hourly. Either they get paid by the hour or they get paid a salary. It doesn't make sense to have both. Same thing, their job type over here, it's either going to be an engineer or an admin, but you're not going to be both. People's job classifications are always some distinct job classification. So the other constraint on the participation in the hierarchy is shown either by a solid line or a double line. So the double line is for total participation. So there's all employees either get paid hourly or salary. There's no third choice or no possibility of anything else. We can imagine a case where there was a possibility. Suppose you had some people who work at your company as volunteers, so they don't get paid either way. But in this one, the employees all get paid and they're either salaried or hourly. On the other hand, the other hierarchy about job type, that one is only partial. So for some reason, we decided to subclass into engineers and administrators, but there may be other people working at the company who don't have any special relationships or attributes. So here we show that the engineer has a special relationship. This engineer works, oh my gosh, it's a typo. It should say they work on the project. So engineers work on projects, and administrators don't. They may have some other attributes like their typing speed or their supervisor, something like that, that other ones don't. But this partial constraint tells us that there can be employees in the database that are neither engineer or admin. There's something else, like a cleaning person or a senior manager. There's neither an engineer or administrator. So those are the two constraints. Not so complicated. Now let's see a kind of more complicated example. So when your slide changes, you will see a very complicated example from the El Masri book. And this is the university database with lots and lots of inheritance relationships. So we see the top of this is person. So in the university database, there's lots of different people who are involved with the university. And the first specialization hierarchy is this one. Also, I note to you that here's this notation with the kind of upward facing U, where in mine it was an arrow like UML. So this top one, we say people can be employees, alumni, or students. And I want you to notice that that is the first example we've seen of an overlapping hierarchy, because it's possible that you graduated from the university, so you're an alumni, and you're also an employee. It's also possible that you graduated from the university and you're still a student because you were an undergraduate student and now you're a master's student. And then we can go down the line. We can see that students fall into two categories. And this one is total, because a student is either a graduate student or an undergraduate student. There's no other choice in this university. And on the other side, we see that there's three kinds of employees: faculty, staff, and student assistants. That's like teaching assistants and research assistants. And what's interesting about this student assistant, you can notice something, that it has multiple inheritance. It's like a TA is both a student and an employee. So in these kind of hierarchies, multiple inheritance is allowed. And when we look at the student assistant, we understand things about it. We understand that it shares so there's a missing underline in their book. It shares the same unique identifier as all other persons in the database, which is, in this case, the Social Security number, the US ID. Because this student assistant belongs to these two hierarchies at the same time, they're both a student and employee. They have all of the attributes of a person, and they also have the attributes of an employee and the attributes of a student. So this student assistant has a major, a salary, as well as the name and address and birthday. And then going down here is that we said, yeah, a student assistant is either a TA or an RA, and depending on which one they are, they have even more special attributes. And this example doesn't show relationships, but as we said, relationships are also inherited. So sometimes like here, subclasses have their private relationships, plus they share the relationships of their superclass. So an engineer participates in two relationships, the works at relationship and the works on relationship. But the other employees don't participate in works on. They only participate in works at. All right, let's look at one more example. When the page changes, oops. The page will change for you to this. This is the medical company database. And in here, we see that earlier we had employees and doctors as separate. But obviously that's not true. A doctor is a type of employee. But it's a very special type because a doctor participates in a lot of relationships that other employees don't participate in. Doctors have this special case that they can work at clinics on different days in different clinics. All the other employees only work at one clinic at a time. I mean, to say they're assigned to a specific clinic and they don't go and work at the other clinics. They also have these supervisory roles. Doctors don't have a supervisor. They're their own supervisor. So doctors don't participate in this supervisory relationship, but they have all these other relationships that are private to them. But all of the workers of this company share some things. They share these attributes, name, address, and phone number. And of course, they share the same ID, the employee ID, which is universal. So doctors have an employee ID, clinic workers have an employee ID, but they do that. So what else do we see about this one is that all employees, it's a total participation relationship here, that all employees are either a doctor or a clinic worker. And no employee can be both a doctor and a clinic worker. But there's no other employees in the database that aren't one of those two types. So it's a very common thing to find. Some of our students actually found relationships like this already in the hotel database because they added some extra entities. And I feel sure that in your next assignment, you will find some relationships like this. So you will need to learn this new style. So do you have any questions? I won't close my slides in case you have a question about an example.
I have a question. I didn't understand what is disjoint and overlapping. It means that an instance can be at the same time inherit from multiple entities?
No, it means that an instance of the superclass can belong to more than one of the subclasses at the same time. So the only example of that was this person at the same time, the same person can be a student and an employee of the university. But all the other ones, you can't be at the same time. You can't be a graduate student and an undergraduate student at the same time. You can't be a teaching assistant and research assistant at the same time. You are one or the other. But this, only the top one is an example of that. I can't think of another example off the top of my head. I think it's less likely to find overlapping, but it's possible. Do you understand?
Yes, I understood.
Okay. Any other questions?
Yeah, I don't have a question.
Okay, then. Thank you very much. I'll stop the recording.